You know, when you really stop and think about it, our universe seems to be written in a hidden language. From the tiniest electron to the biggest black hole, everything follows these incredibly precise mathematical rules. So the big question is, did we just invent math as a clever way to describe everything? Or are we finally starting to learn how to read the universe's own source code? Let's dig in.
Right. This is the heart of the mystery. Is mathematics just a useful tool that we humans created, kind of like a hammer, for building things? Or is it something that's already woven into the fabric of reality, something we're just now discovering? To figure this out, we're going to look for clues in two very different places: the unbelievably small world of quantum particles and the mind-bogglingly vast scale of the entire cosmos.
All right, for our first clue, let's zoom way, way down. I mean, deep into the subatomic world, the strange, beautiful, and mathematical realm that everything we see is built upon.
So everything around you, your desk, your phone, it's all made of atoms. And those atoms are made of even smaller particles, like the electron. But an electron isn't just some tiny speck. Its behavior, its properties, its very existence, it's all perfectly described by this one beautiful formula, the Dirac equation.
Now here's where things get absolutely wild. When a physicist says this equation describes an electron, they don't mean it's just a good guess or a rough sketch. No, the predictions that come out of this math are accurate on a level that is almost impossible to wrap your head around.
Just let that sink in for a second. Imagine a single human hair. Now imagine the entire distance across the United States. A theory, something born from pure mathematics, predicts reality with an error smaller than that hair across that entire distance. This isn't just a good fit. This is something else entirely.
So what does that level of accuracy really mean? Well, it strongly suggests that the math isn't just describing the electron from the outside. It's more like the electron is the physical manifestation of that mathematical formula. In a very real sense, the particle doesn't just follow the rule, the particle is the rule.
Okay, so that was the microworld. For our next clue, let's pull back. Let's zoom all the way out and look at the biggest things we can imagine: planets, stars, and galaxies. For hundreds of years, Newton's theory of gravity was the undisputed champion. He saw gravity as a force pulling objects together, and his math was super accurate, about 1 part in 10 million. But then along came Einstein, who had this totally different, kind of crazy idea. He said gravity isn't a force at all. It's the shape of the universe itself, the actual bending of space and time.
So, how accurate was Einstein's math? Well, scientists watched a pair of stars for 30 years, and they found that his theory matches reality to 1 part in 100 trillion. That's a 1 with 14 zeros after it. It's an insane level of precision. This wasn't just a small update to Newton's work. This was like seeing the universe in high definition for the very first time.
But get this, and this might be the most incredible part. Einstein's math didn't just explain what we could already see. It predicted things we had no way of seeing. The equations said that things like black holes and ripples in spacetime, what we call gravitational waves, had to exist. And it took us almost a full century to build technology powerful enough to actually find them. The math knew they were there all along.
When you see this kind of predictive power, from the smallest particles to the entire cosmos, you can't help but ask a really deep, almost philosophical question.
So where does that leave us? Is math something we made up in our heads to help us make sense of things? A human invention? Or is it a fundamental part of the universe that's been out there this whole time, just waiting for us to notice it?
Basically, there are two camps. The invention camp says math is a useful system we created. The discovery camp says nope, math exists on its own, and we're just explorers mapping out its territory.
And honestly, when you look at all the evidence, the discovery side has a really strong case. How could our equations know about things like black holes 100 years before we could ever hope to see one? It really feels less like we're inventing a language and more like we're just learning to hear a signal that's been broadcasting since the beginning of time.
And this isn't some brand new idea either. It goes all the way back to the ancient Greek philosopher Plato. He argued that there's this perfect, abstract world of mathematical forms, like a perfect circle or the concept of the number 2. We can't touch it or see it, but we can access it with our thoughts. Okay, up until now, we've been talking about math as this super precise tool for predicting reality. But that's only half the story. There's another side to this language, a side that has nothing to do with physics and everything to do with pure, breathtaking beauty. Yeah, for a lot of mathematicians, their work isn't about practical application at all. They explore these abstract worlds of numbers and shapes for the exact same reason an artist paints or a musician composes, simply because they find it beautiful.
There's an elegance, a poetry, an art to it all. I mean, just look at this thing. This is the Mandelbrot set. This isn't a painting. No artist drew this. This is a visual representation of a single, surprisingly simple mathematical formula being repeated over and over. All of this infinite detail, every tiny spiral and filament was just sitting there, hidden inside one simple rule, waiting to be found. And now for the final connection, and this is what just blows my mind. These gorgeous, abstract patterns that mathematicians found just by playing with numbers. Well, it turns out they are literally everywhere in the natural world. You see the same kind of repeating, fractal pattern in the delicate shape of a snowflake, the veins on a leaf, the ragged edge of a coastline, even the spiral arms of a galaxy.
So it all comes full circle. The very same abstract patterns that our human minds find beautiful are the exact same patterns that nature uses to build itself. It's almost like the universe is an artist and mathematics is its favorite medium.
So when you realize that the fundamental laws of reality are mathematical, and the fundamental patterns of beauty in nature are also mathematical, it leaves you with this one final, goosebump-inducing thought. Are we inventing a language to describe the universe? Or are we finally just starting to learn how to read its code?